In the question number 16, when two substances of specific gravity D1, D2 are mixed, equal volume. This is very important point. Equal volume in the case 1. Specific gravity of mixture is found to be ρ1 when they are mixed in equal masses. In the second case, equal masses. The specific gravity of the mixture found to be ρ2. Then we need relation between ρ1 and ρ2. So you can simply solve this question because we know the density for a mixture. I can write m1 plus m2 divided by the v1 plus v2. This one. If I go for ρ1, first one, I will use the same relation. But in this case, volume is same. So I am going to use m1. I can replace in terms of density into volume. So I will write here d1 v plus d2 v because volume are same, v plus v. So I have d1 plus d2 divided by 2 only. But in the case of ρ2, masses are same. So I will use this formula in terms of mass and density only. So I will write m1 m because masses are same, and we can replace volume by mass by density, mass by density. So masses will cancel out. You have only harmonic mean of density just like this, d1 or d2. Now if I go ρ1 minus ρ2 for finding the relation, so I am trying to solve this. So first you will write the value of d1, d1 plus d2 divided by 2. Second you will write this value 2 d1 d2 plus. So I am going to write d1 plus d2 by 2 minus 2 times of d1 d2 d1 plus d2. So when you will take the LCM, you will find d1 minus d2 whole of square 2 times of d1 plus d2. So what I am trying to explain, because by this expression I can say this is a value greater than 0. So what will be the indication? अगर ये 0 से बड़ा है, इसका मतलब negative नहीं है. Means you are taking ρ1 minus ρ2 and you are finding positive value. So meaning of that, ρ1 is greater than ρ2, because that is possible only if ρ1 is greater than ρ2. So I can say my option number 2 will be the right choice. So let's move on question number 17. In the question number 17, volume, rate flow of liquid of density ρ, coefficient of viscosity eta through a cylindrical tube of diameter d is Q, Reynolds number of the flow. So we are looking to find the Reynolds number. So first I would like to write the formula of Reynolds number, ρ, v, d or eta, where v is the speed, d is the diameter and ρ is the density, eta is the coefficient of viscosity. So if I use the principle of continuity, I will write AB. If I go for area in terms of diameter, will write like this. So if I go for the speed v, v is 4 times of q upon pi d square. This is the value of speed. Now because I know the formula of Reynolds number, so I am going to place the value. First I will write ρ, diameter, eta. I am going to replace this speed v. So that is 4 times of q pi d square. So square of d will cancel. So you have only 4 times of density q, pi, eta and d. So by this calculation you can find the Reynolds number of the flow. So my option number 1 will be the right choice. So let's move on question number 18. In the question number 18, on heating a cylindrical metallic rod, the length increased by 2% the area of cross section of the rod. So this is a very basic question. You can solve because you know that coefficient of linear expansion is given by change in length, initial length into temperature difference delta theta. So if I go for the change in length in terms of percentage, will write 2% according to the problem. Similarly, I can write delta r, change in radius, r into alpha into delta theta. So I can use delta R upon R into 100 will be 2%. So by this I can calculate the area pi R square. So if I use the percentage dA over A into 100, pi is a constant value, so there will be no change. So I can write 2 delta R by R into 100, because the value of delta R is 2, so I have 4%. So this is a basic question, because the positive means increase. So I can say my option number 4 will be the right choice. So let's move on question number 19. In the question number 19, the water equivalent of a calorimeter is 50 gram. This calorimeter is used heat 100 gram of water from 10 to 60 amount of heat required to do this. So we can use the simple formula for the heat, mass plus water equivalent, specific heat and temperature difference. So mass is, water equivalent is 50 and calorimeter used to heat 100 grams. So total mass will be 150. I need specific heat, that is 1 according to the problem. And second one, I need temperature difference 10 to 60. So difference is 50. So when I will calculate, I will get 7500 calorie. So I can write like that, 7.5 kilocalorie. So my option number 1 will be the right choice. So let's move on question number 20. In the question number 20, two metallic rod of same area of cross section, very good point, having length ratio 2:3, thermal conductivity 2:3 in terms of ratio, connected in series. So heat current will remain same. This is very important point. Temperature difference as shown in figure, the temperature of the junction is, as I said, in the case of series, heat current will remain constant and heat current is given by Ka theta 1 minus theta 2 divided by the L. But there is a little bit confusion. Sometimes some books using minus sign here, but when you will write final temperature minus initial temperature, then you will write negative sign. If you are looking to initial to beginning, means theta 1 minus theta 2, there is no need negative sign. So okay, in the case of series, heat current will remain same. So I am going to use this formula. So first one, H is heat current. So first I would like to start from theta naught. Theta naught minus 100, and coefficient of thermal conductivity is 2K, area of cross section is A, and length is 2L, and that will be equal to, now 200 minus theta naught divided by 3L, coefficient of thermal conductivity is 3K into area. So this is in general expression. You can cancel Ka, L, L. And try to calculate theta naught. Theta naught minus 100 on the left hand side, 200 minus theta naught on the right hand side. So when you will calculate, you will get theta naught 150 degree centigrade. So by this discussion, I can say my option number 2 will be the right choice, 150. Let's move on question number 21.